So we are going to do energy first. So we have a pendulum, and it goes back and forth, comes back down. We know that total mechanical energy T plus U equals a constant. Can I rewrite T in this situation is 1/2 mv squared? In general, we have been using V's as motion along the x-axis. But this motion is not along the x-axis. This motion is along an arc. You see that? Instead of writing x, I am going to write s for my arc length. As this pendulum swings, it makes an arc. So instead of writing 1/2 mv squared, I'm going to rewrite this as 1/2 ms dot squared, where s is arc length, given by L theta. L is the length of my string, and theta is the angle that this moves. And U is my potential energy, which is equals to mgh. H is the height that this pendulum went up. And we did this whole calculation where H was equals to L minus L cosine theta. So this is the height it goes up, right? If this is theta, this is L cosine theta. The total L is this one. So what should this be? L minus L cosine theta, and that's H. So I can rewrite this as mgl1 minus cosine theta. So I can plug both of these values in here. One half ms dot squared plus mgl1 minus cosine theta equals a constant. Can I say s dot is the same as L theta dot? Does L change during its swing? No. So L will remain constant. Can I take the differential with respect to T? So S dot will indeed be L theta dot because L doesn't change? Okay, good. Can I plug that value up there to get 1/2 ml squared theta dot squared plus mgl 1 minus cosine theta equals a constant? Anybody remember the Taylor series expansion of cosine theta? So the Taylor series expansion of cosine theta is approximately equals to 1 minus theta over theta squared plus theta 4 over 4 factorial minus theta 6 over 6 factorial plus so on and so forth. For small angles, cosine theta can approximately equals theta squared over 2. If it was sine, what would it be? For sine of theta, the Taylor expansion starts from theta, and it's all odd numbers. So theta cubed over 3, theta 5 over, that's how I remember it. So I can plug this in here, right? Plus mgl, what will I get? 1 minus 1 plus theta squared over 2. Cancel and cancel, implies 1/2 ml squared theta dot squared plus mgl theta squared over 2 is a constant. differentiate with respect to t, what will I get? 1/2 m L squared 2 theta dot theta double dot plus mgl 2 theta theta dot divided by 2 equals 0. This means I can cancel this 2 and this 2. And why do we suddenly get a 0 on the other side? Differential of a constant is a 0. So now can I also take away m's and one of the l's? Because it's equals to 0. M certainly is not 0. L certainly is not 0. So what am I left with? L theta dot theta double dot plus G theta theta dot equals 0. Is theta dot equals to 0? Is theta dot 0? No. Is M 0? No. Is L 0? No. So what is the only possibility left? L theta double dot plus G theta equals 0, or theta double dot plus G over L theta equals 0. Is that not the flower equation we were looking for?